just to quick recap from the lecture last time, we learned about inheritance, right? Which is the concept where you can have a class, you can have a relationship between two classes, where one of them is a subclass and the other is a superclass, right? Like, for example, in this case, lecturer is a subclass of the person, and due to the inheritance property, it guarantees that the lecturer will inherit all the access to the attributes of the person superclass. Lecturer can access age, can access name, can access it also inherit the methods, right? Print name and set name as well. But the superclass does not inherit anything from the subclass, right? Inheritance is only one way. The person superclass cannot inherit the lecturer salary attribute, for example. Same thing, right? It cannot access, promote, and compute tax here. And from there, we discuss how to do it, which is to use extends, right? When you do this, Java will automatically see that lecturer is a subclass of the person superclass. This means that it will inherit every attributes and every methods from the person superclass. So you don't have to write these attributes and the methods inside the lecturer class. Okay. We also see that if the superclass has the attribute to be private, right? This attribute, even though it is inherited, it cannot be accessed directly inside a subclass because the private attributes can only be accessed by the class that it is declared, right? Which is the person, right? But the lecturer is a subclass of the person. It's not exactly the person, it's a subclass. It counts as a different class. That's why it cannot access the private attributes. So to do that, you change to protected, right? The idea is protected has pretty much the same as private, except that this attribute is also additionally can be accessed by the subclass of the person, right? So lecturer can be accessed by, the age can be accessed by the lecturer subclass. And also, it also can be accessed by other classes that is in the same package as well. And we also see that if the subclass want to access the superclass method, right? What you can do here is to sorry. If the subclass want to change the behavior of the superclass method, what you can do is to override the superclass method using the keyword override here, right? Add override. And then the subclass can just simply re-implement the superclass method. As in this case, lecturer doesn't just want to print the name of the person, want to add a prefix here, lecturer, right? You can re-implement the print name by adding the prefix in here. Okay. Similarly, not similarly, but this overriding concept doesn't work for the constructor. You cannot override the constructor. In fact, you cannot even inherit the constructor to begin with, right? So in this case, if the subclass want to have a constructor, you have to create its own constructor, but it can still reuse the superclass constructor by calling the keyword super. Super, you can think super as the superclass object, right? In this case, it will match super with the superclass constructor, which has no input argument. But you can also have an input argument inside the super, right? In this case, it will match the superclass constructor with the corresponding input argument, which is integer and string here. You can also use the super keyword as you can think of super as a super class object, right? So you can use this super class object to access the super class method as well. For example, you can do super.setName to call the super class setName, right? And yeah, and this is where we left off, right? Yeah. So you already see the table, right? That if you want to declare the attributes, um, you want to declare attributes, you have 4 modifier, but I already mentioned why we shouldn't use the default. Try to use public, protected, and private, right? Public, if the attributes are public, they are only used for when attributes are constant, right? Okay. On the other hand, if you see that this attribute should be accessed by its subclass as well, then you should declare it as protected. Finally, any other cases, you should make it private, right? So this is the rule of thumb of declaring attributes in Java. Obviously, there would be the question is, what about this? What if you apply this visibility to class and method? What will be the effect? Methods, if you declare methods to be public, it actually follow the same table here, right? The method can be accessed by anyone. Right? Including the classes that are not in the same package. Okay. Similarly, private method also follow this table. If you declare a method to be private, then this method can only be accessed by the class that it was declared. Right? It cannot be accessed by other classes, including the subclass. Yeah. So if you want the subclass to be able to access this method as well, then you should declare as protected. Okay, let's look at the example. Let's see, right? In here, if I have a class called person, and I also have class called lecturer, and if I declare this method print name to be public, right? To print the name, then this print name can be accessed by anyone, right? Including the subclass here. Let's see, I create some dummy method, print details. Then I can call super.print name, right? To call the superclass method that would work. What if I change the public here to be private? Now you see the error here, right? Because you are trying to access the private method, right, that belongs to the superclass, which counts as a different class as well. So that's why Java will not allow that, right? You see, print name has private access in person. So if you want, let's see, go back to public, right? And there I have another class in different package called undergrad student. Okay, undergrad student. Let's see, right? Oops. Then inside, I will create a person object. Move it here. I will import the class so I can see it. Now, what if I do p.set name? So on. Okay, now the Java can compile it normally, but there's no error. But what if you don't want the print name to be accessed by other classes? When you only want print name to be accessed by the subclass, you change it to protected. Protected print name. Oh, sorry. Okay. Sorry. Let me go back. Sorry. I will. Sorry, not set name. I do p.print name here. Yeah, I do set name first, and do. Let me remove this for now. Okay, and do print name. If it's the print name is declared as public, this would work okay. But if I declare print name as private, for example, it would fail, right? But if I declare it as, which is correct, right? Because this class undergrad student, right, is a different class person. So you should be able to access the private method there. If I change it to, to protected, it would still fail, right? Because protected method can be accessed by the subclass and also other classes in the same package. But here, undergrad student is in a different package than the person, right? So that's why you cannot access the print name here. But if you go to lecturer, right, I will copy this code in the main method, you can do the print name. Okay, that works. Okay. So great. So basically, the visibility for the methods are pretty much more or less exactly the same as for the attributes. For classes are also the same as well. So basically, but I'll let you as an exercise for you to do, right? Typically, if you go through that, you will see that most of the time you should declare the class to be public because you want, when you create a class, right, you want that class to be accessed by anyone. So you would want to make that class public so that it can be accessed by anyone, right, including the code that is not in the same package. There's a reason for you to have a private class. Private class means that it can be accessed by the class that is declared, right? This is slightly weird because what does it mean by that, right? So in here, you can use private class to declare a nested class. So you have a class inside a class, right? And you declare the innermost class to be private so that it can guarantee that the only class that can access the innermost class is the outermost class, right? So this works for private class. No access modifier. What if you don't put no access modifier, right? Then this class cannot be accessed outside the package, right? If this use case is what you want, then you put it there. Protected class don't make sense. You can try to think of how, like, what protected means in terms of the class. You should be able to see that protected class don't make sense. Okay, let's go back a little bit on the method overriding, right? For method overriding, to recap a little bit, right? It's a way for a subclass to modify the superclass method, right? For example, lecturer is a subclass or person superclass, right? And you're not happy with the correct implementation of the print name here. So that's why you want to override print name in lecture so that you can put whatever your code there, right? What if when you create a superclass, right, and you don't want the superclass, and say you create a method here, set name, right, and you want to force that all the subsequent subclasses that extend this superclass, they should not be able to modify this method, right? So because if you don't do that, then subclass can override the method by to change the behavior. What if you want to force that you don't want any overriding on this method at all, right? Set name cannot be overwritten, right? Right. If you create a subclass lecturer and extend person, I want to guarantee that lecturer cannot override set name method. So to do that in Java, you can simply use the keyword final on the class. On the method. The idea is to put final in between the visibility and the return type, right? So we declare as public final void, right? Set name. So this, it will guarantee that the subclass cannot modify, cannot override the set name method, right? For example, if I go back to the code, right? If I make set name to be final here, Okay. Then when I try to override set name in the lecture subclass, right, Java will complain that I cannot modify it, right, because the method is final. Once the method is final, it's good as constant, right? It cannot, the behavior cannot change, so you cannot override this method, right? Even in the subclass. So even if I remove final here, it still will work, right? By enforcing final on the method, on the subclass, sorry, on the superclass, you guarantee that this method is final, right? It cannot be overridden later, right? The behavior of this method cannot change later. Okay. What about, can you use the final keyword on the class, right? You know how to use the final keyword for the methods, right? What about if you use it for the class, what does it mean? When you declare a class to be final, that class is final, right? It cannot be changed later. In other words, it cannot be extended or inherited later. It means that you cannot have a subclass of a final class. For example, if you declare the class employee to be final, right? Then when you try to, yeah, if you want to create a new subclass on that, right? By extend this thing, it will fail. It will return error. Java will not allow that. Okay, let's take a look at the real example. What if I declare a person class to be final, public final, right? Let me remove this first. Then you see that there's an error for the subclass lecture, right? You cannot inherit from final class. So once you declare something final, it cannot be extended anymore. You cannot have the subclass of the superclass of the final class. So now we cover the use case for the final for the final keyword, right? You can apply final keyword to attributes, to methods, and to class, right? When you apply to attributes, it means that that attribute is constant, right? Once you assign the values to that attribute, it cannot be changed later. If you apply to the method, that method is final. It means that it cannot be overwritten later by its subclass. If you declare a class final, then it guarantees that this class cannot be extended or inherited later. You cannot have the subclass of the final class. So let's see the rules for method overriding, right? To see which method can be overwritten or not, right? We already see that the constructor cannot be overwritten, right? You cannot even inherit the constructor to begin with, right? Let alone override the constructors. Once you declare a method to be final, right? When you put final in the method, right? That method is final. It cannot be overridden. It will prevent method overriding. Okay. If you don't declare a final, then that method can be overridden. But the overriding method, if you want to override that method, right, you must have the same name and the same input arguments and the same return type as well, right? For example, if you want to override set name, right? In this case, to do that, you have to declare, let's see, the person, right? Lecturer, extend person, that's correct. Override set name, right? Same name, same return type, and same input argument. Okay. If you want to override this method, but if you change the input argument, let's say from string S to string S, that is not overriding anymore, right? It creates a new method. So yeah. Similarly, if you change the return type, right, to int, it's also not compatible, right? So if you want to override a method, make sure that you have subclass to have the same name of the method that you want to override, same input argument, and same return type. Also, if a method cannot be inherited, then it cannot be overridden, right? If you force that the method cannot be inherited anymore, right, then it's not possible to override it, right? That makes sense. So when is the case where the method, when the method is not inheritable? Crap. So the case where the method is not inheritable is when you declare method to be private, right? When you declare the method to be private, then that method can only be accessed inside the same class that it is in, right? It cannot be accessed by the subclass, right? So it cannot be inherited. And also, this also means that it cannot be overwritten as well. And the last rule for the method overriding is that once you override the method, you can change the visibility of that method. Let's say, right, from the public, from private to protected, for example. But the change of the visibility must be the same or larger, right? When you override the method, you cannot have more narrower visibility, right? For example, let's look at example, right? If I want to inherit set name, right? I cannot make visibility lower. I cannot make it protected anymore, right? It would fail. I cannot make it even worse private, right? It would fail. Okay. Let me change the visibility for the superclass from public to protected, right? In this case, if I declare as protected, right, then I still cannot make the overriding method to be private because this visibility is lower, right? I can make it bigger, make it public. Oops, what? That's a different one. Remove this. Right. Okay, I can make visibility larger, and that would work, right? So when you override the method, you can increase the visibility, but not decrease the visibility. So from there, let's see. If I declare three classes, animal, cat, which is the subclass of the animal, and dog, which is the subclass of the animal, right? And each of them, the superclass has the method called move, right, which I declare as protected. And for cat and dog, I override this method, right? And I change the visibility from protected to private in cat, from protected to public in dog, right? In this case, this one would fail, right? The cat class would fail because you decrease the visibility from the superclass, right? When you override a method, you cannot decrease the visibility, but you can increase the visibility from protected to public. That's fine. We will see the reason why that you cannot decrease the visibility in the next 2 weeks. Okay. But now just memorize that. Okay, the last concept that I want to talk about is called class hierarchy. If you don't know what hierarchy means, not the TV show, not current TV show, let me hide hierarchy. It means a system or organization in which people or groups are ranked one above the other, right, according to status or authorities. The picture would be better. So the hierarchy is like kind of a ranking system, right, where you have where you can have the topmost person and the bottom person. Inheritance follow this concept, right? So basically what it means here is inheritance is a transitive property. If employee extends person, and then you have another class called salespersons that extend employee, right? You see, employee extend person and salesperson extend employee. This means that salesperson should inherit everything that employee has, including the stuff that the person has as well, right? In other words, salesperson also extend the person, right? Okay. So yeah, as I mentioned, my salesperson, it will inherit all attributes and methods from both the person superclass and employee superclass, right? Two class above. And when you have different level of classes, right? Two classes above, two classes below, right? For example, like the grandparent class and grandchild class, right? This is called class hierarchy. You can look at this, right? This is a class hierarchy. Basically, I can create like five, 1, 2, 3, 4, 5 classes, right? And the super class, the topmost class is the person, right? That has name, attribute, has get name method. And in here, I can spawn a subclass of the person superclass by having two subclasses, customer and employee, right? Let's focus on the employee subclass, right? Employee subclass, it will inherit whatever the person attributes and method have, right? So it will inherit name and get name there. Then you can add your own attributes. For example, you can add employee number, right, to this subclass. Then you can add get employee number as a class specific method as well. Finally, you can have a salesperson which extend the employee class, right? It will be a subclass of the employee. From there, it will inherit all of these, right, that employee and person have. So if you inherit name, get employee number, get name method, get employee number method, right? Besides that, you can add any class specific attributes, for example, commission and methods, get commission and take order as well, right? Now you can see, right, the classes have ranks, right, have hierarchy, have levels, right? The class below is a subclass of the class above in the chain, right? Salesperson is a subclass of employee. Salesperson is also a subclass of person. Okay. Salesperson is not a subclass of customer, right? Because salesperson is a subclass of employee, and employee is a subclass of customer, right? That's why salesperson is a subclass of customer. Okay. So now, what happened? What if you have class hierarchy and you do method overriding, right? Let's see. I have three classes: person, the topmost class; employee, the subclass of the person; salesperson is a subclass of employee, right? Person has only one attribute name, has three methods: print, set name, and get name. Employee has the one method, set name, that override person set name, right? Salesperson, right? Since salesperson is a subclass of employee, it's also a subclass of the person as well, right? Then this means that it will have access to get name method as well. But you're not happy with the get name method, so you override get name to do something else. Okay, you can do that. So if I write the test code, in this case, I create a person object P. I set name to be Oak, and I will try to get name and print it here. What do I get? So once you do set name, right, it will set the name to Oak, right? When I get name, it will just return my name, the name, right, which is Oak. So this line would print Oak. What about this? I create employee object, right? I do set name to Oak, right? Which set name will be called? This set name or this set name? You already see that employee object already override, right, the set name method, right? So it will change the behavior of the set name. It will not use the superclass method anymore, right? It will use the subclass method. So in this case, set name will go here, which it doesn't set the name to the string input, right? It will just set the name to test. Okay. When it does get name, this one, it doesn't change the behavior of get name, right? So it doesn't override get name method. Okay. But it still can access get name method, right? Due to inheritance. Since it's a subclass of the person superclass, it can access get name, which just return the name. Currently the name is test. This line will return test. Lastly, if I create a salesperson object, right, S, and I do set name Oak, right, you see that the set this salesperson, right, even though it extends the employee, it doesn't override the set name method, right? So the set name method here will correspond to employee set name, right? Not the person's set name, right? So it has two options here: set name here, it for employee and the person. The rule is that in here, if you for overridden method, you start from the class that has the object, right, which is the salesperson class here, and you see that it doesn't have set name, right? You have to go up one more level to the superclass employee and see that it has set name overridden, right? So that's why you have to use this one. You start from the bottom and go up one level at a time, and you stop once you see the actual method you're looking for, which is set name in this case. So in here, it will use this set name implementation, which sets the name to test. What about get name? Get name here, you see that this subclass already have the get name overridden, right? So it already modified the get name behavior. So again, the rule is you start from the class that this object is declared, which is salesperson. See that it has the method that is overwritten, that you want here, overwritten. So you would use this method instead, right? So in this case, get name just return hello string. This line will print hello. Okay. What about if I do s.print, right? Which print do I use? Again, you follow the same rule, right? Start from the class that start that s object is declared, which is salesperson. You see that it doesn't have print method, right? Which means that this method, print method, must belong to the superclass, right? One of the superclasses. So you go up one level to see employee. You go there, you don't see print, right? Then you go up one more level to person. You go there, you see print. So this print will correspond to the person's print method, which would print hello as well. Okay, the last thing is what happens if you do s.name. Yeah. So I'll leave it as a question for you to do. Actually, for you to try. You can try yourself. again, right? If you see name is declared in the super class, right? In the topmost class, declared as protected, right? So to answer this, you have to figure out, right? You also have to consider the case where the test class is in the same package as this class or not, right? The behavior may be different. So I also put more examples in here, and I expect for you to try to think of it yourself, right? Basically, I create a couple of classes, A, B, C, D, where class B extends class A, class C extend class A, class D extend class B, right? And the class A has print method, which is overwritten by class B and class C. And class D also has a new method called setter. And from there, I want to see what happens if I create a D object and I want to call print, right? First of all, can the object access print method here? If it can, what would be the output? And so on and so forth, right? I also have more example, and this one for you to try, okay? And then we can discuss in class. So that's it for inheritance, right? I think we learned the concept of superclass and subclass. We learned that how to implement superclass and subclass in Java to use the keyword extends. And if you write a subclass and you're not happy with the superclass method, right? You want to implement that method yourself. You want to modify the method yourself. You have to override the method. But as a subclass, you can still access the superclass object, right? For example, a superclass constructor through the keyword super. You can access superclass method through the keyword super as well, okay? And finally, we learn about protected modifier, protected visibility, right? For variables, for methods, for classes. We also learned the final keyword, right? That can be applied to variables, method, and classes. And lastly, we see that the classes can be viewed as a hierarchy, right? Where you can have a superclass of the superclass, right? A subclass of the subclass, and so on and so forth, as many levels as you want. That is it today.